How's it going, everyone? It's Holly from West Coast 1000. Today is December 19th, 2020, and today we're obviously focused on this nationwide snowstorm that could happen going into Christmas week. So let's begin by first, obviously, taking a look at the GFS model, and as you can see, it's taking a pretty strong low pressure system, and you see the darker shades of blue right around the northeast, which represent higher snowfall rates and pretty much more snowfall accumulation throughout the Northeast. However, there's still a lot of uncertainty with this, and I want to emphasize this because this is going 6 days out, and a lot could change in 6 days, as you know, with the weather forecast. So there's still a lot of uncertainty, but you see that over the next several days, GFS takes sort of, I wouldn't say an Alberta Clipper. It's coming a little bit too far south to be considered an Alberta Clipper, but it's taking a low pressure system off the coast of the Northwest Pacific, and behind it, it's packing a lot of cold air, and this cold air will be further enhanced by the pressure gradient between this low pressure and the high pressure that's currently located in the North Pacific. I'll show you guys it right now by taking a look at the North American map. You guys will see you see the big ridge that's currently just off the west coast of the United States and Canada, and you see that low pressure system right here. And since they're in such close proximity to each other, there's going to be a little bit of a pressure gradient where the higher, denser pressure that's currently located in the Pacific will try to move into this low pressure system, and as it does so, there's going to be a strong north wind that's going to bring a lot of that Arctic air that further south, which will be the key ingredient to what would later strengthen this storm in the United States. And as you know, when there's a pretty big bump in the jet stream that goes up, there needs to be at least an equal dip in the jet stream as well, because when there's a pretty big ridge or there's a big bump in the jet stream where a lot of warm air is filtered to the north, that usually means that a pretty big ridge or at least a low pressure system during the summer a low pressure system during the winter is usually pretty far up north, and when it's that far up north, it brings a lot of it has a lot of winds within the high or low pressure system, and all those winds have to go usually face southward to the point where a lot of that Arctic air dips down to a point where the jet stream dips along with this bump in the jet stream that this ridge will be causing, because this ridge is going to bring a lot of warm air to the northern Pacific, and as it does so, as the high pressure is a little bit more northward, that means that the diverging winds coming from this high pressure system will be so large and will be so far in the north that the eastern side of this ridge will experience a pretty long duration, long fetch of northerly winds, and that'll create the dip in the jet stream going into Christmas week, and that'll be the key ingredient of later strengthening the storm and bringing a big Arctic blast in the United States come Christmas. And I would say I'm pretty confident that there will be some sort of big jet stream dip coming around Christmas week. It isn't that uncertain that there isn't that much uncertainty in that scenario where we're seeing a big jet stream dip going into Christmas week, especially since we're in a negative Arctic oscillation, as it seems like both the computer models are agreeing that there's going to be a pretty big dip in the jet stream, which will later strengthen this low going into the United States. The exact details of how powerful that dip will be or how powerful the low pressure system will be have yet to be seen, because this could either be extremely just huge Arctic blasts coming through the United States, or it could be smaller like the European is leaning towards. We just have to wait and see how this ridging builds in the northern Pacific going into within the next several days, and we need to see how much of a dip there is in the jet stream, how much wind of a northerly wind component there will be to bring that Arctic air from Canada further south. to determine all those things. And as of right now, the computer models, the forecast models, do not know that yet, as usually it takes several days to process, to really get a good feel of how the ridges and low pressure systems will maneuver over the next several days, since computer models pretty much rely on historical data. And when it's relying on historical data, that means that it's very limited in terms of its long-term forecast, like 3 to 5 days out, since it really doesn't have any, since using historical data, um, it could only go so far, since the forecasters have only been measuring weather data, or a lot of this weather data computed into the computer models, for only about 50 to less than 100 years. So it isn't 100% accurate. However, as time goes on, the computer models will get more accurate, but as of right now, there's still a lot of uncertainty in terms of exact details with how this mid-latitude cyclone will maneuver over the next several days. However, what I could say with confidence is that we will see some sort of snowstorm in the northern United States. I think that's almost inevitable at this point. There's just going to be just enough cold air that both the computer models are agreeing with that. And since we're in an Arctic oscillation, it just seems highly unlikely that there won't be enough cold air in the United States, especially in the northern states, for at least some snow or at least some low pressure formation in the United States. So I do think we will see some sort of snowstorm somewhere in the US. Exact details where and how much, that still has yet to be seen, but I think we're getting more confidence that there will be a snowstorm in the United States. And if we continue to take a look at the GFS model, let me zoom in a little bit to the United States only map so you guys get the better picture. You see that the GFS is not only taking a mildly sized snowstorm throughout the northern United States through Montana and the Dakotas, it's also taking snow as far south as the southeast, where even maybe Atlanta could be involved in this scenario if the snow band extends that far south, and even Alabama, because this Arctic dip that the GFS is forecasting is just going to be so pronounced that a lot of that Arctic air will move all the way to the Gulf Coast states, which could bring just enough cold air for a lot of that rain or thunderstorm activity to change over into snow. And not only that, you see that just north of the Gulf Coast states, you see that there's a pretty hefty band of snow extending from Georgia all the way to Canada, where Canada is obviously getting the most snow in this situation, since it's closest to the low pressure system where all the convergent energy is happening. However, you see that this snow band also extends as far south as the United States and the southeast United States at that. And you see that snow band extends, a new low pressure system forms as a result of this huge Arctic dip in the jet stream, where I assume a lot of this Arctic air is interacting with the much warmer Gulf of Mexico water as well as the Atlantic Ocean. So a new low pressure system has formed thanks to the increased amount of convection caused by by the Arctic air that's zipping over the Gulf of Mexico and Atlantic. And you see that it enhances the snowfall even more, to the point where you see it's almost as heavy as snow could get when it comes to the GFS model and what it's forecasting right now, because you just see the darkest of the darkest of blues all over the Northeast. And this is as a result of just a strong jet stream dip the GFS model is leaning towards, which is just going to rapidly intensify this storm and really give it a lot of convection and fuel for a lot of that humid, warm Gulf of Mexico air and southeast United States air to move to move aloft into the atmosphere and create a lot of convection and thunderstorm activity, just enough so to where you could experience a very heavy snowfall threat in the Northeast and throughout the Midwest and even the Southeast if this scenario is true. And this could dump a pretty good amount of snow. However, what's interesting about this system is that it isn't really a typical sort of snowstorm I'd typically see or picture as bringing a ton of snow, because what's interesting about this is that this isn't really going to be the most snowfall isn't really going to be surrounded by in a mid-latitude cyclone where the low pressure system gets a lot of the moisture wrapped around it, which is typical for a lot of snowstorms in the United States, where usually just north or west of the low pressure system you experience the most snow or precipitation, because that's where a lot of the convergent energy is, and that's where that's where pretty much a lot more humid air is located. You don't typically see snow you typically don't see like snow within a band like this, within like right around the cold front. That's what I'm trying to say. You don't really see snow pretty much ride along the cold front, and the reason for that is that usually mid-latitude cyclones behind the cold front, it's very dry. A lot of dry air filters in to the point where even though the air is cold enough, there's just too much dry air for any sort of convection or precipitation to occur. However, in this scenario, one of the rare cases, it seems like although there's a cold front moving through the United States under this mid-latitude cyclone located in Canada, we're seeing just enough moisture behind the cold front to the point where you could experience a pretty big amount of snow. And this isn't really typical, as a lot of moisture is moving behind the cold front. So this seems to be a very interesting sort of storm. And however, in these sort of storms, which may be good news to some of you if you don't like snow, with these sort of storms, I typically don't really picture these sort of storms producing extremely heavy snowfall amounts or bringing a ton of snowfall accumulation. And the reason for that is that it's just pretty much behind a cold front, and there's only so much moisture that the backside of the cold front could take. And as a result of that, the snowfall amounts usually during snowstorms like this are limited. It's rare to see a foot of snow. However, this could be that rare case where it seems like the snowfall is pretty heavy, and you could see heavier snowfall amounts than you typically see during storm systems like this. So we have to just wait and see. However, what's interesting is that the European model is a little bit less lenient on bringing a strong storm through the United States. And while it does bring a formidable storm, I'm not saying that this storm is completely weak, because it does strengthen it to 990 millibars by the 144-hour time frame. It does it much later, and you see that the dip isn't as pronounced as the GFS model at this point. Because if we compare the two, like look at the European, just take a look at it, you see a lot of the blue colors are in the north, which represent colder Arctic air. And if we compare that to the GFS model, you see that cold air dips far more south, and you see that the storm strengthens to 984 far earlier, and it's decently more formidable than what the European is leaning towards. So it seems like there seems to be disagreement on the strength and sort of the timing of this storm, because at 144 millibars, 144 hours from now, the low pressure in the European is still far south. However, in the GFS, you see it's much farther north, and it's much stronger storm at this point, and bringing a lot of cold air just behind it. So it's going to be interesting to see how the computer models play out, which one is usually correct in this over the next several days, because does increase the uncertainty when we don't see agreement between these two computer models. So we just have to wait and see. However, if the GFS model were correct, then expect a much more major snowstorm through the United States, where you could see a ton of snow pretty much extending from Northwest Pacific all the way to the southeast and up the east coast, to where you could experience a pretty big snowfall event. So just keep that in mind all throughout the northern states. However, I will say with confidence that the Northwest Pacific and the northern Dakotas, the northern Midwest, should prepare for a snowstorm, because whatever happens, whatever strength this is, it seems likely you will experience a pretty decent amount of snow through the Midwest and the northern United States, and this extends to the Northeast, and this could extend to the Northeast as well. So we just have to wait and see what happens with this snowstorm over the next several days. But outside of this potential snowstorm, we also have to pay attention to this sort of weak low pressure system that could form over the next several days, where you see there's a little bit more thunderstorm activity in Louisiana. So you guys need to watch out for that, potentially severe. However, there isn't going to be enough instability to really develop anything major. There might be some rain showers through the southeast and maybe some isolated snow showers through the northeast. However, there just isn't going to be enough cold air or enough instability to really create a ton of convection with this storm. So don't expect anything from that. And obviously there's a low pressure system I was talking about, and just keep watching that all throughout the United States going into Christmas week, because a lot of you guys could experience a white Christmas going into Christmas time and the holiday season. So yeah, I guess that's it for this video. I thank you guys for watching. Make sure to subscribe if you like this content. Make sure to like if you like this video, and make sure to share with friends and family who might enjoy this content. So I hope you guys have a good night, good day, good afternoon whenever you're watching this.